Hello students and welcome to today's lesson. In this lesson guys, we're going to do basic algebra. So this is from learning unit 2 and these are the learning outcomes. So by the end of learning unit 2 guys, you should be able to explain the algebraic rules of substitution, how to expand algebraic expressions, how to factorize, and also we are going to simplify. And then learning outcome number 2, express real world problems as inequalities. Learning outcome number 3, we need to combine functions using algebraic expressions as well. And then guys, we need to set up a linear equation to solve real world applications. And we are going to shift our attention as well, solve for simultaneous equations using the graphical illustration, the substitution method, and also the elimination method. We need to use graphs to illustrate linear functions by plotting points and also using gradient and the y-intercept. Then as well, we use graphs to depict real-world applications, express profit, revenue, and cost using the algebraic expression. And then lastly, we need to identify non-linear equations. Okay, so let's get started. Here's learning outcome number 1, guys, the substitution. So with substitution now, guys, it means you are trying to find the numerical value of the algebraic expression. For example, if you are given the following algebraic expression where you are given x squared plus 5x minus 7. So if we want to determine or you want to evaluate the value of this expression where you are given that x is equals to 4, all we have to do is to substitute 4 into the algebraic expression. Okay, so always guys, when you're substituting, make sure that you open a bracket. So we'll open a bracket, close the bracket, squared, plus 5, where there is x again, open a bracket, you substitute and put 4 minus 7. And then after that, you just press your calculator and find the value of this algebraic expression. So on my side, I am getting minus, not minus guys, let me just press my calculator again. I'm getting a positive 29. So it is very important guys, when you're substituting, to always just open a bracket, you put the value of x. Let's try another example. If for example you're given that minus x squared plus 3x minus 2, given that the value of x is equals to, let us just say, a minus 3. It means now on your side, you need to pay careful attention here. Where you see x on this algebraic expression, you are going to firstly write minus, which minus? This minus. Minus. Minus, we open a bracket. The value of x, it is minus 3. Minus 3 squared. Okay, plus 3, where you see x again, x is equals to minus 3, not just positive 3. You write minus 3, minus 2, and then after that, just put everything in your calculator. You press your calculator and find the value of x. So on my side, I'm getting a value of minus 20. Okay, so please guys, I know that this might look easy, but on your side, definitely need to familiarize yourself with your calculator. That is substitution, where you are trying to find the numerical value of the algebraic expression. And then 2.2 guys, we need to expand brackets in algebra. So I want you to note the following. I will just read there and then I will explain again. If there is a number, a numerical value or an algebraic term in front of a set of brackets with brackets containing a numerical or algebraic expression, then all factors in the brackets must be multiplied by the term in front. Okay, looking at example number 1 guys, let me just explain what I was reading here. They are saying if for example you have 3 open bracket 18 minus 5 close bracket, this is what you need to do. You take a 3 and apply the distributive law. 3 will multiply 8. Then it will be 3 times 8. And then positive 3 as well will multiply negative the negative 5. Then it will be negative 3 times 5. After that, you press your calculator, you are going to get 39. Again, if for example, let me just get another slide here. They are saying, guys, if you have, for example, 3 times, let's say 2, 3 times 3 minus 2, applying the distributive law. Positive 3 will multiply positive 3. Then you will have 9. Positive 3 will multiply the negative 2. Then you will have negative 6. After that, you minus, guys, 9 minus 6, you will have 3. Applying the distributive law first. Then as well, guys, before you expand algebra, please remember the product rule. From the laws of exponents, the product rule. So the product rule, guys, states that if you have, for example, a to the power of 2 multiplied by a to the power of 3, as you can notice, you are multiplying and the bases are the same. What do we have? The bases are the same, we are multiplying. So when bases are the same and also multiplying, you take one base and add the exponents. So it is going to be 2 plus 3. 2 plus 3, then a will be equals to the power of 5. All right, so let us go back now and do the second example. So if we're going to do the second example, guys, I want you to note something very important here. Hope you can clearly see. Here what we have, 3, a to the power of 2, the b is to the power of invisible 1. The 1 is always there, guys. Let me try to maximize here so that you can clearly see everything. So a is to the power of 2, b is to the power of 1, invisible 1, open bracket, for a to the power of 1, b to the power of 2 plus 2a to the power of 2, b to the power of 2, close bracket. So we are going to apply the distributive law and the product rule. So this is what we need to do here. 3 will multiply 4. 3 will multiply 4, then you will have 12. Are we clear? A to the power of 2 will multiply this a to the power of 1. The bases are the same, you are multiplying, you are going to add 2 plus 1. Then you will have a to the power of 3. Then you move to b. b is to the power of 1. This b that I'm highlighting here, and multiply by b to the power of 2. You are multiplying, the bases are the same, you are going to add the exponents. So it's b to the power of 1 plus 2, which is b to the power of 3. Then we move, which means we're done with 4a b to the power of 2. Applying the same process. 3 will multiply 2. It's a positive 3 multiplying a positive 2. You will have a positive 6. And then as well, a to the power of 2 will multiply a to the power of 2. So the bases are the same, we are going to add the exponents. You will have a to the power of 4. 2 plus 2 is 4. Then we move to b. b is to the power of 1. Multiply by b to the power of 2. The bases are the same, we add the exponents. 1 plus 2, you are going to get b to the power of 3. Okay, so as you can notice here, guys, we're applying the distributive law and also we are applying the product rule. So that's how now you expand algebra. Maybe you can try to do another example. Okay, so here's another example, guys. Expanding algebra. So 2 minus 2 will multiply the negative 3. Minus 2 will also multiply the positive 2. And then what else will happen here? x to the power of 2 will multiply x to the power of 3. X to the power of 2 will also multiply x to the power of 2, which means y to the power of 3 will multiply y to the power of 4 and y to the power of invisible 1, applying the distributive law. Now let us continue. Minus 2 multiplied by negative 3. Negative times a negative is a positive. 2 times 3 is 6. And then what else do we have? X to the power of 2 multiplied by x to the power of 3. The bases are the same. We add the exponents. 2 plus 3 is 5. Then we move to y. Y to the power of 3, y to the power of 4. You add the exponents, then you'll get 7. Then let's proceed. Minus 2 is now multiplying again another numerical value, a positive 2. So you're going to get a negative 4. X to the power of 2 multiplied by x to the power of 2. The bases are the same. You are multiplying 2 plus you are multiplying, and then you need to add the exponents. 2 plus 2 is 4. You move to y. Y is to the power of 3 multiplied by y to the power of 1. The bases are the same. You add the exponents. 3 plus 1 is 4. Then you are done expanding algebra. So as long as you know the product rule, guys, and the distributive law. Okay, so let us move to learning outcome number 3. Learning outcome number 3, we need now to introduce factorization, where we're going to factorize algebraic expressions. So factorization, guys, is actually the opposite of expanding algebra. It means now you are going to look for the common factor. So you can just do those two examples, then you will understand factorization. What do we have here? We have 8. This is what I prefer on my side. Just write the algebraic expression first. Okay, so here's example number 1, guys. You are factorizing. You have 8, you have 12. So you're going to start with 8 and 12, the numerical values. They are like terms. They are numerical values. You want the highest number that you can use to divide 8 and 12, the highest common number that you can use to divide 8 and 12 and not get a fraction. So that highest number is 4. Not 2, guys. 2, yes, 2 is common, but not the highest. Are we clear? And then you take out 4 as well. This step, the step that I'm highlighting, is the most important step. So don't miss out on that step. And then after that, you have x to the power of 2 and x to the power of 3. You are focusing on x. Remember, you are trying to find the common factor. So you take between those two x's, guys, the x with the smaller exponent. X to the power of 2, x to the power of 2, and then you take out x to the power of 2. Are we clear? Then you move to y. You have y to the power of 3, y to the power of 4. You need to take out the y with the smaller exponent. Y to the power of 3, y to the power of 3. You take out y to the power of 3. After that, open a bracket. You have your common factor. The only thing that you need to do now is to just divide. 8 divided by a 4. You'll get 2. After that, what do we have? X to the power of 2, and also on your denominator, you have x to the power of 2. They will cancel. The numerator and the denominator, they are the same, and you are multiplying. You have a multiplication sign in between. You can just cancel. Y to the power of 3 will cancel y to the power of 3. We have minus 12 divided by 4 is 3. You go to your numerator. How many x's do we have? We have 3. You take away 2. Then you'll have x to the power of invisible 1. Don't write the 1. It's always there. You move to y. Y is to the power of 4. And then how many y's you have? You have 4. You are taking away 3. You'll be only left with y to the power of 1. Are we clear? Then you are done factorizing, guys. So I hope that example makes sense. Okay, so let's do example number 2. Here's example number 2, guys. 6ab to the power of invisible 1. Write the invisible 1. plus 3a to the power of 1, b to the power of 2. Factorizing again, you want the number that you can use to divide 3 and 6 and not get a fraction, the highest. That number is 3, that number is 3. You need to take out 3 as a common factor. Are we clear? What else do we have? A to the power of 2, a to the power of 1. You need to take out the a with a smaller exponent, a to the power of 1 as your common factor. Happiness. And then what do we have? With b to the power of 1, b to the power of 2. You take the b with a smaller exponent, b to the power of 1. After that, you open a bracket. 6 divided by a 3. You will get 2. You go to a. How many a's do we have? 2. You take away 1. You'll be left with a to the power of 1, invisible 1. Don't have to write the invisible 1. After that, b to the power of 1 divided by b to the power of 1, they cancel because the numerator and the denominator, they are the same. You go to 3, numerator, denominator the same, cancel. A, numerator, denominator the same, cancel. How many b's do we have? 2. You take away 1. You'll be left with b to the power of 1. Okay? So on your side, guys, the only thing that you need to do on your final answer is to remove the invisible ones, and then you are done factorizing. So please practice factorization. And then let's move to learning outcome number 4, simplifying an algebraic expression. So when you are simplifying, guys, you want to leave your algebraic expression in its simplest form. Okay? So, for example, here we are told that we are going to deal with 3 types of algebraic expressions. Number 1, those that can be simplified immediately without any preparation. Okay? Number 2, those that require preparation before being simplified, and those that cannot be simplified at all. So let's look at number 1. Number 1, you need to prepare number 1 and also number 3 before you can simplify. But looking at number 2, guys, you'll understand when I'm doing the solution. Number 2, you can just simplify without preparing the algebraic expression. For example, you have 2y, you have 3x minus 7 minus 8x 4y. On your side, you can just add or minus like terms on number 2. Let's start with number 2. Here, what do we do? You have 2y. This y is to the power of 1. Do we also have another y to the power of 1? Yes, where is it? 4y to the power of 1. So we're going to call them like terms. Why? Because you have y and the exponents are the same. You have 1, 1. So you just add there 2y plus 4y, you will have 6y. Are we clear? Then we move. What else do we have here? Let me just try to maximize fully so that we can get more space. You'll have 6y. So let's move. We have 3x is x to the power of 1, x to the power of 1. You have x and their exponent is the same, is 1, guys. I want you to note that sometimes if you have x to the power of 2 and x to the power of 1, those two you don't call them like terms. Okay, so this is what we need to do. Plus 3x minus 8x. What are we going to do? The signs are not the same. We are going to subtract. You have a positive and a negative. So it will be 8 minus 3. The answer is 5x. And then which sign are we going to take? Going to take the sign of a bigger number, minus 8. After that, we only have one numerical value, minus 7. You are done simplifying the algebraic expression. So number 2 can easily be simplified without preparing. But looking at number 3 and 1, you need to prepare the algebraic expression. So let us just do example number 3. 7a minus open bracket minus 3a plus 4b plus 12 minus 2. So what you need to do here, guys, is to firstly check inside the brackets. Do we have like terms? No. We only have 1a to the power of 1, 1b to the power of 1 in one numerical value. We don't have like terms. The only thing that we need to do now is to just apply the distributive law. Applying the distributive law, you still have that 7a. Let me write here actually 7a, and then minus is minus 1 here. Minus 1 will multiply minus 3a, minus 1 will also multiply positive 4p, minus 1 will also multiply there positive 12. Are we clear? So this is what will happen. Minus 1 times minus 3a, it will be a positive 3a. Minus 1 multiplied by a positive 4b is minus 4b. Then minus 1 multiplied by a positive 12 is negative 12. You still have that minus 2. So the only thing that you need to do is to just add like terms. 7a to the power of 1, 3a to the power of 1. So you're going to add like terms and have 10a minus 4b. Minus 12 minus 2, signs are the same. You add 12 plus 2 is 14. And take any negative between those two, minus 14. And then that's how you simplify algebraic expressions. So let's check if we have other examples. I think we do have, or we can just do more examples here. For example, guys, if you are dealing with the following example, 49 x to the power of 5 y to the power of 3 divided by 7. Okay, so the only thing that you need to do here is to just divide. The 49 divided by 7, you're going to get 7. X is to the power of 5 divided by x to the power of 2. You have 5 x's, you take away 2, you'll be left with x to the power of 3. You go to y, how many y's do we have? 3. You take away 1. From the denominator, you'll have y to the power of 2. It's y to the power of 2. Alright, so that's how you simplify. So the part of where you are just dividing, guys, it is only applicable where you have a multiplication. Can you see where I'm putting the multiplication? But if you had a plus there or a divide, you are just going to find another method. Alright, so let's try to do one more example. Something complex. If you have, for example, okay guys, here's another example. Please make sure that you pay attention. Here you are going to factorize first before you simplify. So this is what we need to do. Z to the power of 8 minus z to the power of 7. You are factorizing the numerator, what you have on top first. Forget about what you have on your denominator. So factorizing, we are going to take the z with the smaller exponent between those two. Z to the power of 8, and then after that, open a bracket. So what you need to do, guys, you take the 7, this 7, the exponent of your common factor, minus 7, take this 7, the exponent of your common factor, minus 7. So on your side, this is what you need to do now. Z is to the power of 8 minus 7, which is z to the power of, not x, z to the power of 1. Z to the power of 1. You move x, sorry, minus first, x, z to the power of 7 minus 7, you'll get a 0. So it means now here, guys, you have z to the power of 0. Anything to the power of 0 in maths is 1. You write the 1. You go to your denominator now. You have 9. you have 9. This 9, where I'm highlighting, which means 9 is common. You move z to the power of 10 and z to the power of 9. You are going to take out the z with a smaller exponent, z to the power of 9. Once you have the exponent there, 9, this is what you need to do. You take that exponent 9, then it's 10 minus 9, 9 minus 9 again. So once now you take out this 9, guys, the one that I'm highlighting as a common factor, you can just disregard the 9 here. You can say you no longer have 9 here and you no longer have 9. Okay, so it means now you only have z to the power of 10 minus 9. You'll get z to the power of 1, invisible 1. You don't need to write. Minus, which minus? The minus that we have here, minus z to the power of 9 minus 9. It will be z to the power of it's not z, guys. We'll have z to the power of 9 minus 9 is 0. Z to the power of 0, anything to the power of 0 is 1 in maths. So what do we do? We'll cancel here, these 2. Why? Because you have a multiplication sign, and whatever that you have inside the brackets is the same. You cancel. It means now on your side, you are only left with z to the power of 7 divided by z to the power of 9. 9z to the power of 9. You need to simplify further. How many z's do we have on your numerator? This is what you can do. Remember, this z is multiplied by 1. You just leave the 1 there alone on the numerator, divided by 9z to the power of 9. You are going to take the positive 7 from the numerator to the denominator. 7 will change into a negative 7. You are applying law number 2, the quotient rule. Okay, then this is what you will have: 1 over 9z to the power of 2. Then you are done. So always try to make sure that you leave your exponents positive. Okay, so we need to move to learning outcome number 3. Learning outcome number 3, guys, we are going to introduce equations. So equations, an equation is a statement indicating the mathematical equality of two expressions. All right, for example, if you have 2x minus 3 is equals to 1, once you have equals to in between, just know that you are dealing with equations. So if you have 2x minus 3 equals to 1, this is an equation. Solving for x, guys, the only thing that you need to do here is to try and isolate x. On your left hand side, you'll be left with 2x equals to 1. You are taking the negative 3 from the left hand side to the right hand side. The sign will change into a positive 3. So let me just utilize the space here. 2x will be equals to 1 plus 3 is 4. And then what you do, x is multiplied by 2. You reverse the multiplication by a division. You need to divide x by 2. Divide on the right hand side by 2 as well. So that 2 can cancel 2. X is equals to 2. Are we clear? So it means now, guys, if x is multiplied by a number such as 2x is equals to 8, x is multiplied by a number, you reverse a multiplication by a division. You just divide by 2, you divide by 2 so that you can cancel 2. X is equals to 4. Okay, when you have the multiplication. But what about now when x is divided by a number? Such as when you have x over 9 equals to 18. Okay, when you have x over maybe 2 is equals to 4. As you can see, x is divided by 2. you reverse a division by a multiplication. It means now you need to multiply x by 2. You multiply by 2 here, you also multiply by 2 on the right hand side, so that 2 can cancel 2, x is equals to 8. So you reverse a division by a multiplication by a division. So I hope that makes sense. Okay, here are some few examples that were given here. If you have x minus 7 equals to 12, solving for x will be equals to 12. You're going to take the negative 7 from the left to the right hand side. The sign will change into a positive. Therefore, x is equals to 19. X plus 7 equals to 12. X is equals to 12. Taking a positive from the left hand side to the right hand side, the sign will change into a negative. Therefore, x is equals to 5. X is equals to 5. Here, another example, x over 6. X is divided by 6. Said we reverse division by a multiplication. We need to multiply x by 6. But what you do on the left, you also do on the right. So that 6 can cancel 6. X is equals to 12. Alright? So what about now if you have 40, x equals to 51, x is multiplied by 40. You need to divide x by 40. You divide on the right hand side by 40 as well. So that 40 on the left can cancel 40. You'll have x is equals to 51 over 40. So guys, I want you to comment below and change this improper fraction into a mixed fraction. So what do we do? The last question here, so this one we're going to do it when we do the inequalities, don't worry. So that's how you solve for x, guys. As long as you know that multiplication, reverse a multiplication by division, a division by multiplication. When you are taking a negative number from the right hand side to the left, or to the left to the right, the sign will always change. A positive from the right to the left will change into a negative. A negative from the left to the right to change to a positive. Always the sign changes. Doesn't matter whether you're taking the letter, the number from the right to the left, or to the left to the right. Okay, so I think now we need to introduce finding the unknown. But before we can find the unknown, I want us as guys to shift our attention to the rules of solving inequalities. Yes, we are still solving for x, but now we're solving for x with inequalities. So number one, if you have x minus 7 greater or equals to 12, so x, it will be equals to, so x will still be greater or equals to 12. You are taking a negative number from the left hand side to the right hand side. The inequality sign will not change. This greater than or equals to, when you are taking a negative number or a positive number from the left to the right, or to the right to the left, the inequality sign does not change. So x is still greater or equals to, you add those two numbers here, you will have 19. What about number 2? X, if you're multiplying or dividing both sides of an inequality by the same positive number, the inequality sign does not change. Okay, so x is divided by 6 here. You are going to multiply x by 6, multiply 2 by 6. Notice we are multiplying by a positive number both sides. Therefore, the inequality sign will not change. 6 will cancel 6. X is still greater or equals to 12. Even if, guys, you have 2 positive 2x equals to 4. Notice x is multiplied by 2. You need to divide x by 2. Divide by 2. So that 2 can cancel 2. Let's say it was less than here. Less than or equals to. So x will still be less than or equals to 2. So when you're multiplying or dividing both sides by a positive number, the inequality sign does not change. Let's move to number 3. Number 3, guys, multiplying or dividing both sides of an inequality by the same negative number changes the direction of the inequality sign. So it means now, guys, if you have minus 3x less than or equals to 6, notice x is multiplied by a negative number, which is minus 3. We need to reverse, we need to divide both sides by minus 3. You divide by minus 3. Minus 3 will cancel minus 3. X is now greater or equals to minus 2. Why? We are saying when we are dividing or multiplying both sides now by a negative number, the inequality sign will change. A greater than or equals to will change into a less than or equals to. With our example here, we're given less than or equals to, it changed into a greater than or equals to 2. All right. So I hope you understand that. Let's do this example, guys. We're going to change the 3 into a negative. Let us just say we have, let me add another slide here. Okay, so this is what we need to do here, guys. You can just apply the distributive law, or you just divide by minus 3 both sides. Was it greater than? It was greater than. Here we have greater than, not equals to. Greater than or equals to. So this is what we need to do. Minus 3 will multiply positive 7. Are we clear? You'll get minus 21x, and then minus 3 will multiply the negative 6. It will be a positive 18. Let me positive 18. Greater or equals to minus 108. Okay, it's minus 21 here, guys. Minus 21x. So you have minus 21x greater or equals to minus 108. You are taking the positive 18 from the left to the right. The sign will change. You will have minus 21x greater or equals to, you add the 2, 108 plus 8, because the signs are the same. The signs are the same. So if signs are the same, you add and take any negative between those two. Minus 126. X is multiplied by negative 21. You need to divide both sides by minus 21. Divide by minus 21. Minus 21 will cancel minus 21. X, as you can notice, we are dividing by a negative number. The inequality will change into a less than or equals to 126 divided by 21. So it will be a positive 6. So please practice, 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 guys. And then what about learning outcome number 5? Finding the unknown value in a formula. So what is a formula? A formula is an equation in which terms are represented by words or symbol. For example, guys, if you have profit equals to revenue minus expenses, this is a formula. Are we clear? Another formula, if you have future value equals to present value, open bracket, 1 plus I all to the power of n. This is a formula. So with formulas, guys, you can be required even with the future value formula, or just try to find any formula and try to make any certain letter the subject of the formula. For example, if you have future value, present value, here you can be required to make n, to make I, to make PV the subject of the formula. Okay, so this is what we need to do now. Let's try to make I the subject here. So making I the subject of the formula, step number 1, we need to divide both sides by PV. Step number 1, divide by PV both sides. PV will cancel PV, then future value over present value. On the left hand side, on the right, what do we have? 1 I to the power of n. So you want to remove that I, to remove the 1 and n. N, guys, remember n is to the power of 1. This n is to the power of 1. To remove the n here, you need to multiply by the inverse of n over 1, which is 1 over n. So what you do on the left, you must also do on the right. Future value over present value is to the power of 1. So now this is what you need to do. You just multiply both sides by 1 over n. 1 over n, both sides. So that on the right hand side, guys, n can cancel n, 1 can cancel 1. You will have the right hand side 1 plus I. On the left hand side, you still have future value over present value, all to the power of 1 times 1 over n, which is still 1 over n. Are we clear? So on the right hand side, you only want I. To have I, you can just take the positive 1. From the right hand side to the left hand side, the sign will change into a negative 1. And then what you do, future value over present value, 1 over n. You are done. Okay, therefore I is equals to future value over present value, 1 over n minus 1. Okay, so I hope you are still with me, guys. I hope you still understand everything. So let us shift our attention now to the linear function. But with the linear function, I think we need to create another recording. So please make sure that you watch part 2, where I will start from learning outcome number 7. Please watch part 2. I will upload part 2, guys. Thank you for watching. I will see you on the next one.